Okay, welcome everybody. The name of our application is MeterMinder, and it's about reducing your home energy and water usage. I'm Sam, I'm the apper. This is Kai and Trevor, the programmers. So the motivation behind our app is based on the fact that buildings consume about 30% of all energy in Canada. And so for larger buildings like commercial buildings or institutional buildings, there's often an architect or an engineer who's involved in managing that energy usage. But for houses, because they're so much smaller and so much more distributed, it's hard to have the resources for that sort of individual analysis. So what we want to do with our app is connect homeowners to their energy usage and quantify that in consumption terms that they can understand, and then provide tools for them to reduce their energy and water usage. So more specifically, our goals are to take consumption information from their utility meters, which actually track how much of each resource they're using, and then combine that with information about the devices in their home and how often they use those devices. And then go out and get weather data from the local area and consumption patterns for their, and then occupancy patterns for their individual home. Combine all that information and provide tools that they can use to save energy and water.
All right, so I'm going to talk briefly about how our code is structured for MeterMinder. It consists of 5 modules, the core of which is the MeterManager, which scrapes information from Toronto hydro servers, and it also allows us to manually input information from the user's gas and water meters in their home. This is augmented by the Location Manager, which uses the phone's GPS capabilities to track their residency patterns and allows us to bin our energy usage into home and not home. The Weather Manager gets the ambient temperature information over time and historically from the internet, and that allows us to calculate heating and cooling loads, which is something engineers would do if they were analyzing the building. And the Tag Manager allows us to use near-field communication, or NFC tags, to log the usage of individual high-energy consumption devices. The information from these 5 modules is synthesized by the Tips Manager, which attempts to provide over time useful information or little pieces of information for the user to help them control their resource consumption patterns.
What you can see here is what we're calling the meters list. And at the bottom that you can just about see is, you can see that we're currently got 3 meters in the app. The top one is a gas meter, and then the Toronto hydro meter, and then the water meter at the bottom. And the pie chart gives you the breakdown of your projected yearly costs based on the readings that you've already entered. So we've been tracking these readings for a while. So I'll just show you the Toronto hydro one. So as Trevor and Sam mentioned, this is showing Sam's hourly energy usage yesterday. And the data comes from our server, which comes from the Toronto Hydro server, which comes from the smart meter that's living in Sam's home. So the blue bars are the hourly data, and in the background, the gray and white regions are coming from the location data. So the Location Manager bins home or not home, and the gray areas are times when Sam was home, and the white areas are time when Sam was not home. So it lets us decide whether the energy usage associated with you being home or not home. So, and I'll just hand over to Sam to talk a bit about the manual meters.
Okay, so for those meters where we don't have automated data collection like we do for Toronto Hydro, we have to actually enter the readings as they appear on our utility meter, which you can't quite see there, but that's fine. So if I want to enter a manual meter reading, I open up the meter that I'm interested in, and then I press the plus button, and then I would log a reading. So I would select the meter that I want to log, and then I would enter the numbers as they appear on the register on my meter. So in this case, I'm going to enter the reading 49580, and enter the time that I took the reading, and then press save. So now the chart is updated, and the pink bars are an indication of the actual consumption. So the last bar is the difference between the meter reading that I just entered and the reading that I entered previously. Now the black line is an indication of how much we would expect this home to consume based on how much it's consumed in the past and what the weather's been like over the last period. So this is a way of determining whether you use more or less than you would expect the home to use. So in this case, I've used substantially less, which suggests that something's happened. Perhaps I've turned down my thermostat, or I've installed a more efficient furnace. This is something that's relatively difficult to do without weather correcting the data like this, because you don't know if you're comparing 2 periods with the same temperatures or 2 periods with different temperatures.
Alrighty, so I'm going to briefly show off our NFC capabilities here. I'm going to do my best to make this visible. So these are NFC tags, and they're little stickers with some sort of wizardy chip inside, and they allow our phone to track the usage of, say, for example, your washing machine, which consumes a lot of electricity and water. So here's, oh, you should know. So here's the tag, and when I touch the phone to it, this is a blank one. Come on. There we go, okay. So this allows me to register a new device, and this tag has now been written with a unique identifying number which lives in our database. Say I'm going to register this, this looks like a, oh Jesus, looks like a clothes dryer here. And then I have the option to configure the device and input information for the model number, or the make, for example. And this is now logged, and I can come back to it. Now, I would actually stick this little sticker on the device in my house. So here's one I've been tracking previously. I think it's a clothes dryer here. When I touch the phone to this one, oopsie daisy, there we go. So this allows me to log the washing machine that this was living in this tag, and it allows me to log it for 60 minutes, and it also gives me some information on how many times I've used it and how much it costs me over the year.
Okay, so all the information that we're collecting in these different pieces of the app is consolidated in the tips page. And what the tips page is really a breakdown of suggestions for the user on what they can do to reduce their home energy and water usage. So, and for each tip we have a dollar value that's going to save them per year, and we also have an amount of each resource that it can save them per year. So the user can really hone in on what they're interested in, be it electricity, water, natural gas, or they just want to save money. So if we expand this first tip here, we can see it's based on the information Trevor was collecting with the NFC tags, and it provides some information on how you can improve the efficiency of that particular device and why it actually saves you money. So that concludes our demo, and we're going to move on to our lesson.
All right. Okay. So this is something we're probably going to hear a bit of, but in our development process, this was a proof of concept application. So we started with the core capabilities first. If we were to start over, it would be kind of nice to have user input on what they'd like to extract from the application, and that would inform our UI choice. So we'd probably work in UI earlier. In terms of technical discoveries, I won't bore you with the details. One thing we discovered is that timer tasks are incompatible with location tracking. You need to use services instead. And guys, going to tell us a bit about future work.
So at the moment, our app only reads from our servers. So one of the obvious next steps is to allow it to write back all the manual meter readings and the location data back up to our servers. And this will allow us to do some neat things. One example is, at the moment, we assume there's only one person or device per home. But if we allowed communication to the server, we could have multiple phones associated with one home, which would improve our statistics. Another example is sharing our statistics, which would let you compare your efficiency to your neighbors. Or if the data is on the server, we could give it to people like Sam, and they could have a much finer grain about information about how real people use their real utilities.
Okay, just a few other things we'd like to do is provide an app tutorial to explain more features, have users test it, expand the number of appliances that users can track, and then include some home experiments for deeper investigation of issues like water leakage. Thank you. Thank you.
At the back. Oh, that's you.
So it's a very useful app, and I'm very interested in using it as well. And I would find it very useful to even have some management app, like reminder for when to do the washing, as well as how long it's being washed, and like set a reminder to actually take the clothes off.
Very, very close to within what this app can do.
I'm familiar with RFID chips for like in warehouses and stuff. Is that the same technology as this near field, or is that different? Or?
From my limited understanding, it's using the same electromagnetic principles to talk back and forth between the tag and the phone. So yes.
Great, thank you.